Okay, thermochemistry, Discovery Education, Chemistry 1.2.2. What is the relationship between a system and its surroundings? Go ahead and draw your Cornell notes, write that essential question, and hit pause and tell me what you know. Okay, so the conservation of energy, also known as the first law of thermodynamics. You know this already. What does it say? Energy can be transferred or transformed, but it cannot be created or destroyed. Okay, there you go. We have it highlighted here directly from first paragraph of your text. Okay. In our example here of the fire, you light the the wood on fire, and it releases thermal energy in the way of heat and light. You also get smoke. You get some ash in the end. What happened here? Well, you transformed all of that matter and energy that was in the form of wood, and it was transformed and transferred into the environment in different forms. Okay, that's not too difficult a concept to understand there. So, but the biggest point, I imagine, is to say that it wasn't destroyed, right? It was simply changed in form. So, when we say that things are, in this case, energy was released into the surroundings or the environment, that begs the question of systems versus surroundings. That's the whole point of this Explore number 2. So a system is a thing that you're studying. If a scientist is studying something, they're going to be looking at everything related to what they're studying as the system. They're going to call that the system. And everything outside of that system would be referred to as the surroundings. Okay. When you take a look at your surroundings, here we go. You have typically 3 types of systems that you're going to be looking at. You have your open systems. That is where within your system and the surroundings, if there's a barrier between them, so to speak, energy can pass between them as well as matter. Both of these can pass across that boundary. Okay. In a closed system, only energy can pass between the system and the surrounding. And in an isolated system, neither energy nor matter can pass between. And this is probably the most difficult one for us to replicate, isolated systems, right? Okay. All right. Kind of moving on here, the second law of thermodynamics here, and again I want to encourage you to be reading your text and clicking on the vocab and watching these videos. That's really the best way to learn this. We're just trying to pull this together into a set of notes for you. What does it say? It says, well, remember in lecture we've talked about, we simplified it and said that things tend to go from order to disorder. It seems like nature wants to find the least energetic state, the most stable state. Okay, so in any natural process, the total entropy, abbreviated with the letter S. So in any natural process, the total entropy of a system and its surroundings must increase. Okay, and remember, entropy is basically that disorder, that idea that there is no energy available to do work. Okay, so we've got this picture here on the left. It looks like this nice structured, organized set of particles, perhaps. We say this is a high energy state. There's a lot of potential energy. You can do work with this. It has low entropy. Over here on the right, you can see that it has kind of spread apart. Okay, filling all the spaces uniformly. This is what we call that disorder. It's a state of high entropy. There's low energy potential in the system. The energy is evenly distributed throughout the area. Okay. So remember, with thermal energy, it moves from high temperature objects to cool temperature objects until thermal equilibrium is achieved. Okay. If you were to run back up here, you could imagine that this was heat, and it flows out into from hot to cold, and until there's an even distribution until you've reached thermal equilibrium. That's just taking this example and trying to transpose it onto our example here. But remember, there's basically three ways that energy transfer occurs: conduction, convection, and radiation. And that should really just be a review for you. If not, refer back to Explore page 1. Okay, or actually even refer back to heat. I'm sorry, go back to chapter or the first concept in this unit. Okay, all right, well, that's it. Go ahead and write down what you learned, and we'll talk to you soon.